Good afternoon, guys. Today we are going to talk about the selection sort. In previous class, we talked about the sorting, what is sorting, and bubble sorting algorithms. We already studied in previous class. Now we are going to talk about the selection sort. So selection sort is one of the sorting algorithm that selects the smallest element from an unsorted list in each iteration and places the element that element at the beginning of the unsorted list. Set first element in the list as a minimum. First of all, we are in this list, the 20 is the first element. You have to set this element as the minimum element compared with the second element, which is the minimum element. So compare this element with the second element. So if the second element is smaller than the minimum, then assign the second element as the minimum element and compare with the third element with the minimum element. If the third element is smaller than the minimum element, then assign the third element as the minimum. And this process continue until last element to sort the list of elements in an ascending ladder. So let's assume that we are going to consider an array, a list. We'll consider an array, a list of elements 20, 12, and 10, and 15 are 15, who are the elements in a array. First of all, according to the selection chart, we have to select the first element as the minimum element. Then you have to compare with the second element with the minimum element. In case if the second element is minimum element when compared to the 20, then the second element becomes as the minimum element. Then you have to set the minimum element as the 12 now. So now again we have to compare with the minimum element to the next adjacent element. So now my minimum element is 12 and compared with the next element is 10. So 12, whenever we are going to compare with the third element with the minimum element, if the third element is minimum element when compared to the 12, then 10 become as a minimum element. 10 become as a minimum element. Now my minimum element is 10. So next again we have to compare with the 50 with the minimum element. So the 15 is not a smaller element when compared with the minimum element. Then no need to be then no need to be assigned the minimum. Now then no need to be assigned the minimum element. Just you have to compare with the next element with the minimum element. Fifth element is compared with the minimum element. So if the fifth element is smaller than the minimum element, then you have to set as the minimum element as the 2. Once it is set as the minimum element, the minimum element it should be placed at the first index position. First index position. That means after each iteration, placing the minimum at front of unsorted list. At front of unsorted list. So that's why 2 should be placed the minimum at front of the unsorted list. So once it is done, next still it is not at in a sorted order. So again we have to do the same selection sort process. For each iteration, indexing starts from the first unsorted element. Step 1, 2, 3, repeat until all the elements are placed in their correct position. Now, my next I'm going to consider the second element as the minimum element compared with the third element. If the third element is minimum element when compared to the 12, then 10 becomes as the minimum element. Then we have to compare the next element with the minimum element. 15 is compared with the minimum element, but it is not a minimum element. Then we are going to move to the next element. 20. 20 is not a minimum element when compared to the 10. Right? So the no node to be moved to the element. But after performing the iteration, 10 and 12 will be swapped. 10 and 12 will be swapped. Now these are in ascending order. Now these are in ascending order. See here, the minimum value is still again, we have to do the same process. Next, we are going to consider the minimum toll is a minimum element compared with the 15 element. 15 is not a minimum element, then no to be set as a minimum element. Then you have to compare with the next element, 12 and 20. 12 is the 20 is not a small minimum element when compared to the 12. So 12 is the minimum element. So it is already in correct position. It is already in a correct place. So next we are going to consider the 15 element. 15 element set as a minimum element. Set as a minimum element in unsorted list. These minimum element compared with the next element. Next element is 20. 20 is compared with the minimum element. So it is 20 is not a minimum element. So 20 is a greater than the 15. So then no notice will stop here. It is already in a correct place. So next we are going to come set the minimum element as a 20. There is no further elements in an array. So that means now 20 is also in correct position. So this is the way to we have to run the sorting in selection sort. So this is the way to we have to write the program for the selection sort. So first of all, we have to declare the variables because at least we require the one array because we have to store the elements in an array. And N is nothing but it is the size of the array. And I and J are the iteration purpose. And we have to, according to selection sort, we have to take the first element as the minimum element. So that's why we require the minimum variable also. And we require the one more temporary variable. After swapping, whenever we are going to do the swapping, at that time we have to store the elements in the temporary variable. So that's why we are going to declare the one more thing. And here, first of all, we have to enter the number of elements that should be in an array. First of all, we have to read that n value because it is the size of the array. That means how many number of elements should be stored in an array that should be represent the n and enter the integers. Here, because we have to, while we are going to enter the integers, we are only do the sorting the elements in a numeral in a numbers only. So that's why we are going to consider the integer. Otherwise, you have to do the some other, you have to declare the another data type. No, don't worry. So now we are going to uh, enter the elements in an array one by one after another. We have to insert the values into an array with the help of this scan method. So after insertion the all the elements one after another, likewise we have to insert the all the elements in an array. Then we have to find the minimum element. So that's why we are going to consider the I equal to 0, I less than n minus 1, I plus plus. Why we are going to take the finding the minimum element n minus 1 times? Because first we have to consider the first element as the minimum element. So that's why minimum equal to I. That means the first element I equal to 0. The first element set as a minimum element. Once it is done, next we have to compare with the next element, second element. So that's why I plus 1. J will be declared as the second element. Compared, if array of minimum element is greater than the array of J, then the second element set as the minimum element. Right? So in case it is not a minimum element, then we need to do the swapping. Then only we need to do the swapping. Minimum element is not equal to the I, then we need to be swap. This is the way to we have to swap in the elements by using selection sort. And next topic we are going to talk about the insertion sort. Insertion sort. So insertion sort is nothing but it is one of the sorting technique. By using this sorting technique, we have to arrange in the list of elements in a particular order, whether it is ascending order or descending order. Insertion sort algorithm arranges the list of elements in a particular order. In insertion algorithm, every iteration moves an element from unsorted partition to the sorted partition until all the elements into the sorted in the list. So let's assume that the first step is the first element in the list is in sorted portion and all the remaining elements are unsorted portion. Take the first element from the unsorted portion and insert that element into the sorted portion in the order specified. Repeat the above process until all the elements from unsorted portions are moved to the sorted portion. So consider the following list of elements 15, 20, 10, 30, 50, 18, 5, 45. So assume the first element is the 15th element in a sorted portion. And to place the element 20 to be sorted portion compared to 20 with its previous element 15, right? So 20 and 15. If the second element is smaller than the previous element, insert the second element at its correct position. At its correct position. So to move to the 50, to move to the next element, to move to the next element compared with the 10. So 10 is compared with the previous element. 10 is 10 is lesser than the 20. Then we have to swap the elements. Then we have to swap. After swapping the elements, we will get there to like this. Then we have to compare with the previous element. So 15 and 10. 10 is smaller than 15. Then we are going to swap these elements 10, 15, 20. After swapping the elements, we will get the array like this 10, 15, 20, 30, 50, 18, 5, and 45. But still, it is not in a sorted portion. But still, it is not in a sorted portion. Next, we have to move to the 50. Next, we have to move to the 50 from unsorted portion to sorted portion. Compare with the 50 with 30, 20, 15, and 10. Since 50 is larger than all the sorting elements, 50 is inserted directly onto its sorted portion. And next, we are going to take the 18. 18 is compared with the now to move element 18 to its sorted portion compared to 18 with the 50, 30, 20, 15 and 10 elements. So 18 is compared with the 15. Then we have to 18 is smaller than the 15. Then we have to move to the swap. Once after done the swapping, again we have to compare with the previous element. 18 is compared with the 30 element. 30 is the